All right, before you can add vectors mathematically, you have to understand how to break vectors into their individual pieces. So that's what I want to do here. So I have a vector 32 meters per second at 30 degrees, and let's go ahead and let's give a little dot back here, a period, to give myself two sig figs all throughout. What you need to understand is each vector has two separate pieces. A tail to tip, in fact. There's an x piece, an x vector, and a y vector. We're going to use the word component here. Okay, so I have an x component. I have an x component, and I have an x component here and a y component there. Okay, in other words, if I can take a vector, this resultant vector, and break it into its two individual pieces, its x piece and its y piece, whenever I'm adding multiple vectors here later on, I can add all the pieces up very, very easily. But you'll see that that's in the future to come. You just need to know how to divide them into its individual pieces. So coming back in and kind of rewriting here to make sure we don't miss, this is a hypotenuse of a triangle, 32 meters per second. They also give us the angle reference to the x-axis, 30 degrees, right? So to find the opposite side, let me label it y, right? Because this over here is going to be the opposite side of my angle. So to find the opposite side, I'm going to need to use sine. Sine of my angle is going to equal opposite y over the hypotenuse, 32. So just working some math around here, I got sine of 30 equals y over 32. 32 sine 30 equals y. So y comes out to be 16. Now, for the x component down here, so the base side, right? Here's my angle. This side is the adjacent side, so I'm going to want to use cosine here. So cosine theta, remember, is adjacent over hypotenuse. So cosine of 30 degrees is x over 32. So multiply the 32 to the other side, it's in the denominator, right? 32 cosine 30 is going to equal x. So here x is going to come out to be 27.7, or with sig figs 28. So here's what I need you to see really fast. Here, check this out, and this is always going to hold true for both of them. Whenever you need the y component, or the vertical component, okay, y is always, let's actually get the right color here, y is always going to come out to be your vector. I'll put it as r sine theta, where theta is measured reference to 0 degrees, or reference to the positive x-axis, okay? And your x component will always come out to be r, or the actual vector length, okay? Your x component is r cosine theta, where theta is once again being measured to the positive x-axis, or 0 degrees there. If you have the angle measured relative to the positive x-axis, then you just need to burn in your minds sine for y's, cosines for x's. These videos, the videos that you saw yesterday, the videos you're seeing today, those are already up on my website. So if you need to go back and review anything, please feel free to do so. Another thought for you, on days that I'm out, you can always email me or text my email if you're comfortable doing that. The way you would do that is you would pull out your cell phone, and in place of a phone number, you would instead put my email address, lburch, B-U-R-C-H, at pinehillschools.org. and then write a little message. If you're working on a problem, remember you can take a picture of it and text me that picture. It's an MMS, right? And I can get the picture, look at the work you're doing, and then reply right to your cell phone via text message from my email account. So just a few thoughts for you on that.